Hi, my name's Martin Bolton. I'm a lecturer at the University of Johannesburg, and this is my rotational casting machine, which is manufactured from local available resources and designed to be as low-cost, repairable and adaptable as possible. It forms part of my PhD project at the University of Johannesburg, Department of Industrial Design. It's a two-part silicone mold with a rigid plaster support and a small 3D printed mold plug, which you can see allows for the mold to be placed in the machine and only then resin filled into the mold. This presented machine has a useful bed size which is approximately 300 millimeters by 300 millimeters by 300 millimeters. The frame construction and modular design allows for construction with basic workshop machines, and it suits disassembly, repair and replacement. The materials are all obtained from local material and component suppliers within Johannesburg, and some of the notable components are as follows. All structural steel is standard 19mm square steel tubing, which is very low cost and can be customized for different mold bracing solutions. Standard 100mm mild steel square base plates were used for the motor mounts, and these can be customized to suit different types of motors and easily interchanged. All metal components were welded where needed and designed to be disassembled easily for repair. All fasteners were standard M4, M6 or M8 fasteners with weld nuts and screws. Both of the drive motors are standard 12-volt windscreen wiper motors, which were purchased from a local auto spares store. The motor control and power supply is a 12-volt standard power supply with standard off-the-shelf motor speed controls, which were bought from a local electronics supply store. The housings in this prototype were 3D printed due to COVID lockdown, but standard electrical enclosures are easily able to be used. Several of the 3D printed components were used, which include 3D printed bushes, bearing holders and the control box, but these are able to be switched with more robust components now that material and component supply restrictions are lifted. Although the prototype has only recently been completed amongst the COVID-19 lockdown restrictions, its promising capabilities are able to be shared with the maker community and will prove beneficial for manufacturing many types of small products. A larger machine with similar control system, bolstering larger, more powerful motors, will be able to cast even larger products. The way forward would be to make the plans more accessible so that others can attempt to try and replicate the design locally in Johannesburg, and possibly on social media platforms for others to critique, advise or use the design for the benefit of the community. This would also provide the space for the interrogation of the cost of the machine versus what the market would perceive as a suitable purchase or build cost. This project illustrates effective utilization of social media as well as open source platforms to develop new technologies appropriate for different geographic and economic settings. Thank you very much, and you can contact me if you are interested.